Right, thank you, ladies and gentlemen. Now we are moving to the very important session. This is keynote speech session. So in this session, our honorable keynote speakers will deliver a presentation and will be followed by a dialogue session later. In this first keynote speech session, our keynote speaker is Professor Dr. Trio Adiono. He is a professor in Institut Teknologi Bandung. He is about to present future trend in edge computing AI processor. Artificial intelligence become a key technology in society 5.0. In this first keynote speech session, the dialogue session will be led by Dr. Nico Suranta as the moderator. Without further ado, I give the floor to Professor Adiono and also Dr. Suranta as the moderator.
So, thank you for the opportunity given for me to lead this keynote session. My name is Nico Suranta. It is my pleasure to welcome my previous supervisor when I did my master degree, Professor Dr. Trio Adiono, as a keynote speaker in ICOBAR 2020. Firstly, I would like to read the biography of the Professor Trio Adiono. Professor Dr. Trio Adiono received a bachelor and master degree from Electrical Engineering, Institut Teknologi Bandung, Indonesia, and doctoral degree from Electrical and Electronics Engineering, Tokyo Institute of Technology, Japan. Now he is a full professor in Electrical Engineering, Institut Teknologi Bandung. His research interests are wireless communication, DSP, FPGA, and smart card. He's an author of more than 200 publications in journals and conferences. So today, he would like to deliver the speech about the future trend in edge computing and AI processor. So as I know before that Professor Trio Adiono doing research in system-on-chip design, previously in wireless communication design, but now I think it's moving to artificial intelligence processor. So I think we will hear some interesting story from Professor Trio Adiono today. So I would like also to explain, if the audience have any question, please write in the chat comment. I would collect the question at the end of the Professor Trio presentation. So I will deliver the question by audience from the chat column to the Professor Dr. Trio Adiono. So without further ado, please welcome Professor Dr. Trio Adiono.
Thank you very much, Dr. Nico. Distinguished guests, ladies and gentlemen, thank you for your time. So today I would like to deliver my speech regarding to the AI, especially in AI processors. I would like to share my presentation. Okay, so this the title of my presentation is a future trend in edge computing AI processors. So maybe in here is not all people background is electronics and IT, but hopefully it can give us overview about the advance of AI in current stage. So my focus is in AI, but more detail is actually on the processor for the AI. So as you know that we are on the stage of revolution of industrial revolutions. So before at the beginning, we have industrial 1.0, and for the agrarian is society 2.0, and then on the society 3.0 for industrial society. And now we are on the transformation, yeah, from society 4.0 to society 5.0. So in this transformation, there is a key technology that make us become changing, or there is a new disruptive technology. So the technology that is advanced now is because of AI, IoT, and blockchains. So this is the key technology, yeah, that make society 5.0. So this key technology, yeah, makes society changing. How do they do communications, yeah, and how do they doing their job, and how society doing communication each others. And during this COVID, many thing is also changing, but it's still according to the revolution 5.0. So in this COVID situation, yeah, AI can give several solutions to us. So I would like to present a little bit technology from AI that we can use for solving the social distancing problem. So these several technology using AI, we can detect the people, and we can measure the distance between these people. So the red means that they are too close, so they do not make a social distancing. So this is also the application of AI for mask detection. You know that now we have to use a mask. However, not many people are using the mask. So this can be used for controlling the people. And we use a camera for checking the distance, yeah, what they are doing. It can be happen because of the AI technology. Yeah, you can see here, mass detections, yeah, and the distance between people, yeah. And also in the office, we can check also the temperatures, check the person, what is their temperatures, yeah. And also this is the latest from the Amazon. They not only detect, but they also guide the people. So the people in the office will work, yeah, towards the guideline of the light here, yeah. So they just follow this in order to make sure that they apply social distancing. Yeah, this is an example of how the AI can make revolutions in our life. And many other applications actually, not only for the COVID. We can see that's like a self-driving car, yeah. It's also use AI technology to detect the route, to detect other cars and others. And also, you know, that's there is also like a Siri in Apple or in Baidu. They do a real-time translation. So now people with a different language can speak each other, yeah, without knowing, without learning about the language. For example, the Chinese people can speak to English people, yeah. And also the Japanese people can talk with Indonesian with a real-time processing in their smartphone application. And also application of AI in biomedics is also, there are a lot. Yeah, for example, this to detect the COVID symptoms in the here. So it can make a detection diagnostic about if there is a problem with their respiratory system. And the AI now is big intelligent compared to the people. We know that for the people, in order to be able to identify that these have problems, yeah, we need to learn from the elementary school, yeah, senior high school, university, yeah. But in terms of machine, we can learn it, yeah, in matter of time. And also many autonomous devices like small drones, yeah, can also have autonomous control, so they can deliver on reach their targets without any guidance. So they can do autonomous navigations. And also people now building the humanoid robots, we can speech and give an expression for real-time communication with the people. So in the future, maybe it can change some of the job of the people. So in this AI technology, if we see, what is the ecosystem? Yeah, the ecosystem actually in the industrial 4.0 or 5.0, they have an ecosystem. Yeah, at the end there is a company that's make services, to the people. Yeah, like now there is a Gojek, Traveloka, Bukalapak, and others. Actually, they are making a business, making something that applied to people in Industrial 5.0. But actually, what is in the background? In the background, it will not happen because of the surface technology. Yeah, there is a cloud computing services. Yeah, there is a data analytic services. There is autonomous vehicle or fintech technology and smart metering and others. And if we see more detail, actually at the background, there is another technology, which is applied technology, such as IoT, 5G, robotic, AI, virtual reality, that make all of these services is available. And at the core technology, actually, it's happened because there is a chip inside it. Or maybe, there is a processor that make it happen. You know that AI technology actually already started, I think from 1965, or before, but it not become a very big recognized technology right now without the advanced technology in chip developments. So today, my presentation basically how we make this core technology, to make all of this technology happen. As you know, that's when we use AI for a real application, actually we have two ways of application. First, we do computing in the cloud, or we do computing at the edge. Basically, these two different things. Yeah, you know that's if we do computation in the cloud, which is most of AI algorithm now doing, it will require high bandwidth, because every device has to connect with the cloud by the internet. And also in the cloud, actually we need a very high computation capability. Yeah, we have to invest on high performance computers, and it causes a long latency. So you send the image from many camera to the cloud, and cloud doing a computation and send back to you. So you get a response very late. However, this cloud system is suitable for the training because, in AI, in order to apply certain application, we need to teach the AI with the data set. And this training process require a long time processing. And it can be done in the cloud because it has a high computation. And then it's good for the algorithm of AI, which has a deep or big network. However, we also have an application of AI in the edge. What is the edge? Edge means the one that's very close to the customer, such as the smartphones, camera, IoT device, drone, or smartwatch. These are different cases. At the edge, we don't need the internet connected because we're doing computation at the edge. We're doing computation at smartphone. Actually, you don't have to connect to the cloud for doing AI. And if you have a computation at edge in the camera, you can do AI computation at the camera, yeah, and also in IoT or drone. Drone need a very fast response, so it cannot connect to the cloud and doing computation at the cloud. However, this is suitable now for the small network. It means the algorithm of AI using the simple one, not the complicated one. And then currently, there are a lot of hardware for this edge computation device, yeah, for doing AI at the edge. Yeah, first is using general purpose processors. So actually, we can implement the AI using small computers, using the smartphones, yeah, using the processor inside it, yeah. However, is low power efficiency, so the consumption of power is not efficient, yeah, and the performance is also not so good, yeah, because in AI you have a performance which is such as accuracy, yeah, power consumption, and others, which is I will explain later on. The second device that you may use for this edge computation of AI is GPU. I think everyone in this area know that most of people now use the GPU, yeah, graphical processor unit, to do AI, because the nature of GPU, yeah, can do parallel processing. So for AI algorithm, they can do it efficiently. The third one is FPGA. FPGA is more on the, it's such as a blank chip that you can customize it for the AI purpose. This one is much better, yeah, for the AI application compared to GPU and GPP, yeah, because it's customized, yeah, so efficiency and the performance is better. And the best performance actually is using ASIC or custom chip, yeah. It has a high performance, high design, low, however, it's high performance, but the design cost is very high. And the flexibility is low because it cannot reprogram. Like now, we want something that flexible, because application of AI can change from time to time, yeah. At the right-hand side, you can see that this is the GPP from the Intel, and this is the GPU from the NVIDIA, and IBM also produce IBM True North chip, yeah, for the AI, and Google also make a TPU. So this is just a background for you for the AI. I think for the people already know a lot about AI, they know these things. Just introduction for you, that AI actually has two parts. First, the training. Training is we are giving the training data sets, data that to make the hardware can doing detection, classification. Yeah. For example, here we want to detect the fruit, which is this is a banana, this is apple or others. So we give an example to the AI system, and then it doing a iteratively, yeah. As output, they will give what we call weight. Yeah, weight is something that's a value which is used to classify that this is a true fruit that we are targeting. The second is inference. Inference is we apply the weight data, yeah, so it can detect the picture, any picture, even the picture that we do not train for it, yeah, the new picture, it can guess what is this picture is. For example, this detecting apple, so it can make a prediction, 95% it is apple. Yeah. So basically, I want to show that there is a training and this inference. Training is very complicated, and doing in iterations need a lot of computation. So usually we do it in the cloud. So what is the problem in AI edge device? The problem is computation is very intensive. So it consists of many computation, especially what we call the multiplication and add operation. For the famous algorithm like AlexNets, you can imagine that they have 724 million multiplication and add operations. The second thing, it's very memory intensive. So it you see here, they need memory access, 2 giga access. Yeah, it's very big. So they need to transfer data from memory to processor. And also it's a requirement of high accuracy and high frame rate. If you have a processor of AI, you need it has to be high accurate. For example, you want to detect a people, you want it to detect exactly the people, and you want to have a very high response. So if you have a camera with 30 frames per second, so you want it to detect 30 times in a second. And also there is an increasing portable device like smartphones, which is have a very low power. And also form factor, we need it to be very small, and it's powered by battery, and the response is very real time. So this is the problem of AI, if you want to make it. So I said that it's a very huge computation in AI. What actually the computation? Computation is simple but very intensive. So we want to match, for example, this is an apple. We divide the apple into, you want to take the apple on the left, and we break down, for example, the character, okay? Character, we want to detect A characters, for example. So we divide the character into several parts. For example, A character have a corner, have lines, have a vertical lines, so we detect it, yeah? So we match it with the feature in here. So I can illustrate it in this video. The operation, we call it a CNN, convolutional neural network. So basically it's match the image with the features. For example, this is A characters. We match it with several features like a corner, vertical, horizontals, and finally we match it to the real characters. And you see here's 92% it is A, yeah? So AI can detect the A characters. So we can apply this for the character recognitions. We can apply it for the car plate detection and automatic translation and many others. So these were basically the operations. It's doing a convolutions. Yeah, for student maybe already learn about the convolution. We match its features, yeah, many times. These to figure out why the computation reach too many, yeah, giga operation that we require, yeah, and then it's dominate the operation. The convolutional network dominate the operations, and every now this operation is become bigger because we apply to many things. So, yeah, we need more accuracy. So it's become bigger means much more computation is required, and also much more memory access is required. And inside it is also, there is a neural net, which is called a fully connected layer, which we connect each cell with many routes to do each computations. And this is the famous algorithm that is now used. In 2012, the best is we call it AlexNets, and 2013 is overfit. You can see this the accuracy the accuracy is getting smaller means error is become smaller. You can see on the red points, these are accuracy of people detecting something. Yeah. So the last one, the ResNet here, the accuracy is become higher than humans. Yeah. You can see that now machine is become smart compared to the people. Yeah. As we see on this graph. Yeah.
Okay, I think we have a connection problem with Prof. Trio. I will try to call the Professor Trio to log in back to our Zoom. Please wait for a moment.
Sorry, I think it's disconnected. Is it okay now?
Okay. It's okay. Please continue, Prof. Trio.
Okay. Okay. I think the last one is this one. So this famous algorithm, AlexNet and others. I think I already explained about this. Okay. So basic operation of this algorithm all is the same, but it has a different accuracy. Yeah. The best accuracy is this one. Yeah. But basically the operation is the same. Yeah. And the difference is number of layers. And also people doing implementation in FPGA. So this is a Microsoft Brainwave platform that we can implement most of this applications. So we have this for the FPGA also. To increase the performance. And this is an example of NVIDIA give a NVIDIA Jetson Nano. It's very small. It costs only 1 million rupiah. This also from Google, we call it Google Coral. And also from Intel, Intel Movidius, yeah. And also actually inside the Apple smartphones, they also have AI accelerators. And also in Huawei, they have it in Kirin, and also in the Qualcomm, which is mostly the the Android device use. Yeah, they also have accelerator for AI, because the AI is used for example, you are doing a searching or a photo enhancements. They use AI basically. And these device like TensorFlow Lights, and then mobile deep learning from Baidu, and Coral ML from the Apple. So most of the vendors now also provide the AI for the embedded device. So what is the performance of the AI? Performance of the AI, this is the correctness of classification that you do. Yeah, you don't want it. We measure with throughput. Throughput is how many passes per second that the device can do, or how many giga operation it can do, then can do detection. And also latency. Latency is the time from starting from data acquiring, and the output is better because you need a fast response, especially like you need to have a small latency. And the fourth is energy efficiency. You need a high, you want to use a battery usually and you want to use it for longer time. And next is flexibility. You want to change it from person detection to voice detection and others application. So you need flexibility of processor. And the last is cost, of course, small to lower cost. And when we want to, now I'm focusing how to make this hardware actually, because my background, basically the chip, because my background is processor, chip design and others. That's why I'm moving from the Asian to AI and also be doing a smart card and others. So my view is how to make hardware much more efficient for this AI computation. You can see that when we're doing a computation of AI, basically we can do it in floating point, or we can do it in integer or a fixed point, like a 8-bit only. Yeah. It will give you very good result, very good accuracy, but it's too expensive for product it's using, and also need a lot of computation. And also in terms of chip area, this is a chip actually. Chip area is bigger, a chip is more expensive for the chip. So you can see that if we move to the 8-bit computation, it's very small. And you can see that the size is very small, power consumption is very small, yes, if you use 8-bit only. That's why what I'm going to say that if possible, don't use 32-bit floating point operation, but use smaller one, 8-bit or maybe 16-bit in implementation. So this is the basic method, but of course this will require a different expertise. Yeah. First, you can do optimization in hardware-oriented algorithm. So it means algorithm level. People doing a computer science can do in this level. Yeah. And the second one is architecture level. How you make a processing system for that. Yeah, how you design a processor for that. That's, we call it architecture level. How to make a device on that, like a memory, RAM, and others. Yeah. And for the algorithm, yeah, I think it's quite interesting for computation people. We can do quantization, we can do weight data reduction, and we can do weight compression. So this is a basic method that we can doing approach on each application. In architecture of processing, yeah, and you can do optimize by data reuse, yeah, and then we can do utilize sparsity and others. Later on, I will make a detail on this, yeah. First, doing a quantization. For doing quantization, it's basically to changing, yeah, from the floating point operation to the fixed point operation. So I said before, if we do in 32-bit, it's very expensive. So we do it in only 8-bit or even only 1-bit. This approach, we call it quantization. We reduce precision of weight in AI and also in activation. So it's extremely efficient and memory access. Yeah. So you don't need a big memory process for doing that. It's also, first is fixed and the second is binarization. Yeah. So this is an example. You see that if you use a floating point, the data is very big. Yeah? You need a 32-bit. If you make it a smaller, like a 8-bit only, yeah, it's mean the memory that you need, it's become smaller. Yeah. Of course, there is a impact on accuracy, but the impact on accuracy is not so big. Yeah, only 1% accuracy loss. Why the loss is very small? Because using this 8-bit, we can do retrain on the AI. Yeah, by doing a retrain, you can reduce the loss of the, because of the bit reduction. Yeah. And then from 32-bit to 8-bit, we need a rounding algorithms. Yeah, rounding algorithm become a key factors. So this is the one of suggestion using stochastic rounding, so you can improve the performance. And you can see that the evolution from 2012 up to 2020, yeah, people starting with 32-bit. But now they go to only 1-bit. Yeah, 2019 they did 8-bit. Yeah. So it is the evolution of doing the design. So this is how the representation. This is a 32-bit. It is 8-bit. I think this we already know what this. Yeah, in every. Dynamically, we change which one is 16-bit, which one is 8-bit, yeah, which one is 1-bit. Can we change it in order to optimize the hardware without reducing the accuracy of the system. Yeah. So this is the result that we have done in our lab. So this is the result of computation of detecting. Yeah, here for 32-bit, these are the results. And this 8-bit result. You see, it's almost the same. Yeah, they do correctly detect the cat here, but the false detection of the lion at the right. The 32-bit is also false. 8-bit is so it means 1-bit. Yes, so the filters become very simple and design very smaller. We do pruning, methodology weight reduction. So the number of weights in AI reduction. There's a 2-way in here. The first is pruning. The second is sharing or doing a cluster. Yeah. So you can see in the graph. The basic idea of this pruning is you see here's the filters. So this is a basic idea of filter that we multiply with the input image. Yeah. And then if the data is very small, yeah, and then we do, if very small, we make it a 0, yeah, like this. So many 0, it's mean we simplify the structure of computation. So it becomes very simple, yeah. It can save many computation using this pruning. This is our experiment on lab. Previously, this is a computation for the tiny yellow operation. There is a 13 layers. So we reduce it a lot. The blue one, the original one, the red one is the result of the reduction using the Pruning algorithm. Yeah. So you can see that we can save, if I'm not mistaken, this from 32 megabyte of storage. Now we require only 6 megabyte. Yeah, there are a lot of reduction. So this is a result. You can see that this is without a pruning. Yeah, and without also quantizations. And the right side, we're doing both quantization and pruning. So the result is still the same. It's correctly detected. Yeah. It means the accuracy is not degrading. Yeah, even it's much better, I think. For the right hand people, it's more better. The last one is an algorithm is using weight sharing. Weight sharing means one weight, if the value is similar with its neighbor one, we make it the same value. Yeah, so we call it weight sharing. Yeah, and people call it deep comparisons. Yeah, so it's like this one. If it is like a similar, these are many variable in here. Too much variation in here. We make only 4 variation. Yeah, we make 4 variation and give it an index. So we store only in the index. So we put it's only the index. So it's saving a lot of memory storage. Yeah, but it needs a code book, which can be done in pre-computation. Yeah, and this is the result. The result is still the same. It's very nice, yeah. It's only need 5 bit. This one is need only 4 bit, and even this one is only 3 bit. It's smaller than 8 bit. Yeah. So it's a good approach for this one. Minutes there, do still I have? Do still I have the time? Excuse me. Is it okay?
Yes, it's okay. Please continue, Prof.
How many minutes still I have time? For presentation, I mean, later on the question is okay. You are mute. Okay, could you unmute?
Yeah.
Dr. Nico?
Maybe 10 minutes?
10 minutes, okay. Okay, another approach is doing a compression, because we're doing in pruning, make it many zero, so the computation is not too much. After that, we can do compression, like maybe you know zip compression, it's similar like zip. Like this, there is 2 0, you just put 2, is 4 0, just put 4, and data become very small. Yeah, we do it with run line coding. And we can save also the power, because with the 0, you don't need a computation. And then this in architecture level. In architecture level, we can do computation not only using one processing element. We can make it parallel many processing element. Yeah, we can use architecture of SIMS. It's been a single instruction, multiple data. Yeah. And also using data flow, we can use it many processors. So because the computation is similar, and we can do it iteration for many part, so we can share it with many processors. Yeah. And then we need to do the sharing. Yeah, not read the data every time from the memory to the processors, but we can make stationary. For example, the multiplier, we put it on the multiplier or weight, we put on the processor. So we need only read the data. So we call it this is the output. Output is stationary. The result we just put on the processor. No need to put in memory, so you don't need to call it back. Or you can do a weight stationary. You just call the weight, yeah. You just put the weight, but the data you call it. Or input stationary. So the image data you put and the weight you read every time. So these three alternatives for doing weight sharing. And then this Google TPU architecture actually. In Google TPU do matrix multiplication. So they make special design multiplier, yeah, using matrix architectures, yeah. So they can do parallel processing for AI with a parallel, very, very big multiplier they use. And this is Eyeriss from the MIT. They use array processors, yeah. And then there is a buffer here in order to not every time read data from DRAM, yeah. In order to not to, so it's saving a lot of time to access the memory, yeah. So they make it as a chip from MIT 4x4 millimeters. And it can reduce 10 times energy reductions compared to GPU, yeah. This is the ASIC, the last option of implementation, which is the most efficient and high performance. And this is from Stanford. Yeah, they make a sparse architectures. So they make a processor that can detect if there is a zero. Yeah, they don't do computation. They just skip the computation and they use the array of processors to do the computation. Yeah. Okay, this is the last method that I want to show. People doing in memory, yeah, they call it computation in memory. You know that we previous approach doing computation in digital using a processor in here, and the data is read from DRAM. And there's a buffer in intermediate. You know that accessing DRAM, yeah, consume a lot of power. You can see here, LU accessing DRAM is 200 times more power compared to you do it only in the processors. So the idea is how to integrate between memory and processor become one processors. We call it computing in memory technology, yeah. So these are architectures of computing in memory. So it merged all of these things into memory. So less data transfer. You don't need to do data transfer anymore because the data is already on the processing unit. So it's a more energy efficient. And it's parallel because the data is available. They can do it a computation in parallel, everything. So, so this is the state of the art. Actually, in the future, most of the AI will use this technology. We call it deep in memory. Yeah. So it's memory access and computation is combined. The design is maximal computation. And it's significant reduction of energy and latency. Yeah. Now the approach is in the left. Yeah. We make differentiate between RAM and processors. So this is the benefit of using this computing in memory. You can see that read takes in parallel, perform multiple computations. Still a challenge. Yeah. Because it's done in analog, not digital. So there is non-linearity problems. There is a sensitivity to process temperature and others. Yeah. So there is still challenge, many challenges. So people now working toward this approach. But you see here, energy efficiency can be 10 up to 1,000 more efficient, yeah, compared to previous or conventional approach. So this is architectures. So this memory that they made for this one, this from Taiwan, yeah, which will collaborate with us for this research also. And the last is memristors. So they're also doing computation in analog. So they change the resistance of the device and doing a summation of current as to imitate the multiplication in digital computation. And I want to show that these are our results of our processor, but we designed it on the FPGA. We apply a pruning, yeah, we apply also weight reductions. So this is a reduction. We use a low-cost FPGA, which is around $400 US, yeah, to do person detections. Sorry, it's not moving. I don't know, it's moving or not.
I'm sorry, it's not moving, Prof. Trio.
Not moving.
Yes.
Okay, later on maybe I'll show you. I don't know why here not moving. Yeah, actually this is a video, but it can show that it can detect in real time using smart camera, IP camera. We make a prototype of this one. Okay, this is the final conclusion. So the AI edge processor is memory access bounded. It means it's limited by memory access. And then they can significantly reduce chip size and power consumption. And the method that I show can extremely reduce power consumption also because many parameters we can put as a 0. It can significantly reduce computation number. And then accuracy can be maintained by reducing computational and memory access resources. Computation in memory has a potential for extremely low power for next generation AI processors. Sorry that I don't put the reference, but some of this presentation I take from the tutorial from MIT, yeah, and many from the publication ISSCC. Yeah. Okay, thank you very much. That's all my presentation. I give it to the moderator.
Okay, thank you very much, Professor Dr. Adiono, for very interesting speech. So if I try to conclude, Professor Dr. Adiono developed a chip for AI application, especially for the edge computing devices. So maybe for your information, before usually the device, the AI computation is usually done in the cloud computing because it has high complexity. But if maybe Prof. Trio can correct me, to make it run smoother in the device, so the Professor Trio tried to design the chip that can make the AI is implemented on the hardware level. So it includes some simplification like quantification or some memory processing and so on. So maybe that I can summarize. So Prof. Trio, we have some interesting questions from the audiences. So actually we have like 5 until 6 questions here, but I try to pick the questions that related to the hardware design. So because Prof. Trio Adiono is the research is in the hardware design. The AI application is the one that he will try in this research now. So first, I try from the question from Mr. Bayu Kanigoro. So Prof. Trio, there's a question. In several publications that implement AI in FPGA, they emphasize more inference in their implementation in FPGA and conduct training using GPU or cloud. So the question is, does the future design of AI in FPGA continue to emphasize model like this? inference in FPGA and training using GPUs, or the training process also carried out in FPGAs? So maybe Prof. Trio, is it clear for the question?
Yeah, okay. Yeah, yeah, a good question. Basically, FPGA, there is two benefits. Yeah, they put the low-cost FPGA and also, yeah, maybe only around 200 or 100 US dollars. So using this FPGA, you can implement for inference only. Yeah, because in inference usually you deploy many things. So, but FPGA also used for the cloud computing. I think Microsoft doing that, yeah. So they put a very big FPGA to do computation, yeah, for the training, I mean, yeah. It can be used for training and put it on the cloud, yeah. So like, I think Amazon, Google, Microsoft, Azure, yeah. Maybe in the future, they use FPGA for their computing cloud. So there will be option for you. Now, if you see on the services in the cloud, you can only choose a GPU or CPU. But I think in the future, FPGA could be one of the solution for that. Because using FPGA, you can make many approach. Yeah, if you use just GPU or CPU, maybe you can only doing optimization in terms of parameters, but using FPGA, you can employ also other method that I said, like clustering, pruning, and compression and others. Yeah, but of course in inference, yeah, now the best for the FPGA. Yeah, because FPGA used for custom or tailored specific AI algorithm. Yeah, so it's much more efficient. Yeah, if you use FPGA compared to the GPU. GPU is more general purpose, I think. Yeah, so it's been as a conclusion, FPGA both can use for inference for edge device and also can use as the computation for the cloud. Yeah, but the high performance ones, not this small one.
Okay.
Thank you.
Okay, thank you, Prof. Trio. So there's another question. This is from Mr. Cheng Wawan Senggoro. Is it possible to make an FPGA or ASIC for specific AI architecture in Indonesia? So maybe Prof. Trio, can you explain about your experience? Maybe develop some AI to ASIC for specific AI architecture and maybe about the production.
Yeah, so that's why what we are doing now as a focus. Our research now, we are doing this. We collaborate with, maybe you know, NodeFlux. Yeah. So we use for the low-cost ones. Yeah. It's possible in Indonesia for the FPGA. Yeah. FPGA can cost around 400 up to several thousands US. I think still affordable for Indonesians. The low cost performance maybe 200 or 400 US dollars. The expensive one starting from 800 to 3,000 US dollars. I think it's possible for Indonesian to do that. And for the chip also, we do not start it yet. Yeah, but the problem for chip, we can do it in Indonesia, but the problem is the process for the chip, we need the advanced process. I think 65 nano process. For this one, we are starting to collaborate with Taiwan. Maybe if you want, you can collaborate with other university outside Indonesia, like Taiwan. Maybe they have a good process for that, and or Korea, yeah. But possible doing some part of the design in Indonesia, but doing a processing outside of Indonesia. So that approach what we doing in ITB. Thank you.
Okay, thank you, Prof. Trio. So you mean the manufacturing is done with Taiwan? Is it correct?
We are starting to collaborate, not yet process it. Yeah.
Okay. Okay, so maybe one more question this is from Mr. Dr. Michael Sie. Despite advances in parallel and deep in memory computing, is there any other option allowing to use AI processor effectively and efficiently for modeling and algorithms that are very sensitive to small errors? So is it clear, Prof. Trio?
Yeah. I think there is this one, the latest advance that I saw is from Stanford University and MIT. Actually, we are writing proposal also with them. They make it in carbon nanotube. This advanced technology. Yeah, I saw their publication also in ICC. Yeah, so they make a 3D AI. So many memory and many, but using carbon nanotube, I think that's the latest technology, which is very small. Yeah, not many design can be used using this kind of technology yet, but they're doing this approach. MIT doing this, and there's some publication that you can see. Yeah, so this is the latest advance, I think, so far that I know. Thank you for the question.
Okay. Prof. Trio, thank you. So I think we still have 5 more minutes, so I can go with one more question for Mr. Armansyah. So in manufacturing, AI is needed to reduce experiment and test through prediction in the forthcoming results from the process. But the problem in manufacturing, the data are not much due to require much experiment and tests that require a lot of cost. How can AI can be used to do prediction by using not much of data from experiment and test? So maybe it's not related to the hardware device, but
actually, the first step of the design is algorithm optimizations. To doing optimization on the training is quite tricky. Yeah, many training doesn't means you get the most accurate, because overtraining can go also toward false detections. So I think by so far as I know, we need to do training and get the parameters, best parameter that make sure you're doing the optimum training for the data. But the AI itself, actually the algorithm almost fixed actually. Yeah, I mean, you can easily get the shared algorithm from the internet. Yeah. And the main difference is actually how you're training it. Yeah, what data is you train it. So it means that now for the application itself, the most valuable thing is the data itself. Yeah, that's why maybe you know that when you share your image into the public's social media, actually they will use it for training maybe. Yeah, they will know what is the trend of the clothes, what is the trend for the spectacle, what is the trend of what people, something like that. So I just want to emphasize that data is more useful, compared to the algorithm itself now. Yeah. Okay. I think a little bit there's a response, I think, here. What is the overtraining? So I want to continue with this question. Overtraining means if you train it too much with a certain training data set, so the AI will cannot adapt to the new data. Yeah. So if you train it many things about your photo, for example, you give this photo, you give this photo, this is you, this is you, this is you. And if you give him another picture of you, which is completely different, they will not detect you. So it's mean overtraining. Yeah.
Okay. Maybe it's okay. Yeah. Thank you, Prof. Trio, for answering the question. So maybe I try to summarize for the end of this keynote session. So the artificial intelligence become a key technology in society 5.0, and there is a need for some edge processing device like IoT device, smartphone, robot, and card, and etc. And there, yeah, the Prof. Trio Adiono and team now is doing a research to develop the hardware-based AI implementation on the edge computing device. So I hope good luck for the Dr. Trio Adiono and team. So for the last, I would like to present the certificate of the keynote speaker. Yeah. So Dr. Trio Adiono, this is our certificate of appreciation. Thank you very much for your keynote session today. So the certificate is awarded to Professor Dr. Trio Adiono, Institut Teknologi Bandung, Indonesia, for sharing his valuable knowledge as a keynote speaker in the International Conference on Biospheric Harmony Advanced Research, ICOBAR 2020. Okay, thank you very much, Prof. Trio.
Thank you very much, Dr. Nico. So,
okay, see you again next time.
Okay, see you.
So I will return to the Master of Ceremony.